Hi Amri, let's talk about numbers today. You remember the natural numbers?
You mean the numbers 1, 2, 3, 4, 5?
Yes, this list of numbers is what we call the natural numbers. They are the ones we use all the time in counting things, for example.
You said list. When you say list, I somehow think of a list of things to do or my shopping list. This seems like a longer list.
Well, my list of things to do is a very, very long list. I've been postponing doing these for a very long time now.
Long list maybe, but it's still finite. I think the list of natural numbers is an infinite list.
Yes, that's true. This is an infinite list. So sometimes we call such infinite lists of numbers as a sequence.
I remember when we talked about Gauss, how he added the numbers 1 to n at lightning speed, and we got these numbers, the sum of 1 to n.
Right, that was what we call the triangular numbers, and they form a sequence too. So it's 1, 3, 6, 10, 15 and so on.
So now you seem to list only the first few numbers, and I guess we can guess what the remaining are, right? After 15, it should be 21, and one can figure out. You leave the rest to imagination.
Right, so I mean those are the three dots that we always write. Of course, it's not possible to write down every single term, there are infinitely many of them. So we just sort of write the first few and in some sense leave the rest to the imagination. But leaving things to the imagination can sometimes land you in trouble too. So let me ask you a question. So here's a sequence that I wrote down: 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. What do you think are the next three terms of this sequence?
Oh, it's easy. I mean, these are just the odd numbers, right? So 19, after that you'll have 21, 23 and 25.
Right, okay. So 21, 23, 25 would be the next three odd numbers, and so you think this is just a sequence of odd numbers that I have written down. But what if I tell you that I was actually thinking of something slightly different? I was trying to write down the sequence of numbers, the list of numbers in which the digits which appear are all odd digits. So for example, here's what the sequence I was thinking about would look like. So the first few terms are the same, 1, 3, 5, 7 and so on till 19. They are the ones which involve only the digits 1, 3, 5, 7, 9, which are the odd numbers. But after that I can't get 21 because 21 has the digit 2 and 2 is an even number, right? It's an even digit. So of course I don't want that. I am trying to write down numbers which only have odd digits. So that was what I was thinking about. Numbers with odd digits only.
But you can't possibly write down an infinite list of numbers, can you?
Right, you can't, and so that's that's the problem. If I only tell you the first few terms of a sequence, it's not always possible to figure out what the other ones are. You may think of it as one pattern, I may think of it as a different pattern. Sometimes there is no obvious pattern that we can find, and that's the reason why what we need is usually a precise way of defining the terms of a sequence.
Precision is, after all, one of the fundamental tenets of mathematics and hence an essential part of mathematical thinking.
Yes, absolutely. And one way of precisely defining a sequence or the terms of a sequence is through a formula. So what you could do is to write down a formula for the terms of the sequence. So here's the formula for the triangular numbers, if you remember from our discussion of Gauss. So we said let's write a sub n to be n into n plus 1 by 2. Okay, what does this mean? So n now takes the values 1, 2, 3, 4 and so on, all the natural numbers. And when I write a sub n, what I mean is this: the a1 is the first term of the sequence, a2 is the second term, a3 is the third term and so on. And to find the first term, I just plug in n equals 1 into this formula. So, if I say a1, what I mean is I have to write 1 times 1 plus 1 by 2, and that is 1 into 2 by 2, which is 1. Now, a2 likewise is 2 into 2 plus 1 by 3 by 2, sorry, that is 3, and so on. So, you just substitute different values of n into this formula and you will keep generating subsequent terms of this sequence. So, that is one way of precisely saying what any term is, and once I give you this formula, there is no need for any pattern or imagination or anything like that. If you have to calculate any given term, you can just calculate it, whether you do it or I do it or anyone else does it, we will all get the same answer.
So, you can calculate A100.
Yes, you can calculate A100, and that is what Gauss did, if you remember. He calculated the sum of the first 100 numbers, and that is just 100 times 101 by 2, which is exactly 5050, the answer which Gauss gave his teacher in just a couple of seconds.
Do you always need formulas though? I mean, sometimes it's difficult to find a formula, right?
Correct, yeah. So, what you want is to have some precise way of defining the terms of the sequence. Formulas are one way of doing it, but it is not always required. Sometimes you can also do it through some precise rules. So, here is an example. Here is a rule which will construct all the natural numbers. Okay, so I will give you sort of two rules. I will say, write down a sequence whose first term is 1, okay, and the second rule says that each term is obtained from the preceding one by adding 1 to it. Okay, so what does this give us? It says, it sort of gives you a rule. I mean, there are two rules here, so you apply them together. It says the first term is 1, and now I apply the second rule, which says that to obtain a term, all I have to do is look at the previous term and add 1 to it. So, how do I get the next term? Well, I just look at what's before it, which is a 1, and I add a 1 to it, right. So, I get a 2, which is obtained as 1 plus 1. Now, how do I go to the next term? I look at the term which precedes it. So, in this case, I look at 2 and I add 1 to it. So, I get 3 and so on. So, this is how I form all the terms of this sequence through this very precise rule.
What if I change the rule a little bit? So, the first number, let it remain 1, but each term of the list is obtained by adding 2 to the preceding term.
Right, you can do that, and when you do that, what you will get are exactly the odd numbers. So, let us look at that. So, the first term is a 1, and then each term is obtained by adding 2 to the previous term. So, I add 2 to the previous term, I get 3, I add 2 to this and I get 5 and so on. So, what I make in this way is just a list of all odd numbers.
Can we have more complicated rules even?
Yeah, sure. You can have as complicated a rule as you can imagine. So, let us see, let us try and make a far more complicated rule than the one that we have made up so far. So, here is a rule for a sequence. So, again 2 rules. So, it says first term is 2. Okay. And how do you find the next terms? So, it says each subsequent term is, well, what is it? It is the smallest number bigger than all the previous terms. It is obtained as follows: the smallest number, which is bigger than all previous terms, but is not a multiple of any of them.
Okay, so after 2, the next number, the next number is 3, and that's not a multiple of 2.
Right.
So after 2, we get 3.
So after 2 you get 3, that's the next
then-
biggest number which is not a multiple.
Then you get, 4 is a multiple of 2, so we leave it out. 5, now 5 is not a multiple of 2 or 3, so the next term is 5.
Correct.
6, that's again a multiple of 2, so we leave it out. 7 is not a multiple of 2, 3 or 5, so we have 7. 8 is a multiple of 2, 9 is a multiple of 3, 10 is a multiple of 2 and 5, 11 is not a multiple of any of the previous terms.
Right.
And 12, and then it looks like 13, 14 is a multiple of 2, 15 is a multiple of 3, 16, 17 comes next.
Right.
This looks like the sequence of primes.
Absolutely. So this is nothing but the sequence of what we call prime numbers.
Is there a formula for this sequence of numbers?
So we'll talk about prime numbers in a later discussion. So there isn't a formula which tells you exactly what the nth prime number is. So just like we wrote a formula last time, for the previous sequence for the triangular numbers where we said it's n into n plus 1 by 2, there is no real way of writing some nice formula in terms of n which will tell you what the nth prime number is. It's one of the great unsolved problems of mathematics at this time. But the fact, even though we don't have a formula, we still have a precise rule. So, as long as I give you this proper rule, any one of us applying the rule will always get this exact same sequence, and that is the important point.
So we have specified a sequence by specifying its first element, and having specified any element, we have a specification for the next element, and this uniquely specifies the entire sequence.
Exactly. And so what we have seen is, you can give a sequence in one of two ways. You can either write a formula for it for the nth term, or if you don't have a formula, you can give a rule which tells you how to manufacture each term one by one. So there are two ways of writing sequences.